Hello everyone, I welcome you all for the video lecture. The topic to be discussed is tree ADT and tree traversals. A tree is a nonlinear data structure. It represents data in a hierarchical relationship. A tree consists of nodes, edges. The first or the top node is called the root. Each node can have 0 or more children. Examples of tree data structure in real world are file and folder structure, organization hierarchy, HTML or XML document structure, database indexing, artificial intelligence decision trees. The tree terminologies are the root, parent, child, leaf node, internal node, edge, degree, height. Degree is the number of children of a node. Depth is the number of edges from the root to a particular node. Height is the number of edges in the longest path from a node to a leaf. Subtree is a tree formed by a node and its descendants. Ancestor is any node that occurs on the path from the root to a node. What is an abstract data type? Abstract data type defines what data is stored, what operations can be performed, without specifying implementation details. So it focuses on what operations are performed and not how they are implemented. A tree ADT provides operations such as create, which create a tree, insert, add a new node, delete to remove a node, search to find a particular node, find height, determine the height of the tree, find degree, determine the number of children, traverse, visit all nodes in a specific order. So these are all the operations that can be performed in a tree data structure. The types of trees are a gender tree, where a node can have any number of children. Binary tree is a tree in which each node has at most 2 children. There is a maximum of only 2 children. Binary search tree is a tree where left subtree contains smaller values and right subtree contains larger values. Complete binary tree is a tree where all levels are completely filled, except possibly the last. A full binary tree is a tree where every node has either 0 or 2 children. Balanced tree is a tree where height is maintained approximately at logarithmic level. A binary tree is a tree in which each node can have at most 2 children. The children are called left child and right child. Here we have a tree representation where 10 is the root, 20 is the left child, 30 is the right child, and the leaf nodes are 40, 50, and 60. So a binary tree node in Python can be represented using the class node define initialization of a self and a data. And we have self.data is equal to data to hold the node value. And initially we have the left and the right values as none. So creating a binary tree in Python, so we give the node definition, and then we need to create the binary tree. Here we assign the root with a node 10, and then the left and the right with 20 and 30, and then to the left of left as 50 and left of right as 50, thus creating a binary tree resulting like this. Thus coming to the end of the session. Thank you.